Hello everyone, welcome to SVHA Knowledge Point. In this video, we will look into the categorization of explainable AI. Explainable AI is categorized into different things based on different factors. So, based on methods, we have intrinsic explainability and post-hoc explainability. Based on types of explanation, there is global explanation and local explanation. Based on model dependency, we have model agnostic and model specific methods. Based on the stage of explanation, we have anti-hoc explanation, post-hoc explanation. Based on target audience, there are expert focused explanation and non-expert focused explanation. Now, we'll look in detail about all these categorization of explainable AI. Intrinsic explainability versus post-hoc explainability. We'll start with intrinsic explainability. In this, the explanation is built into the model during the training phase. This is applied to inherently interpretable models, that is, the models that are naturally interpretable without the need for any additional tools. So these models are transparent and directly interpretable. By just looking into their working mechanism and the architecture, we can say how the model makes a certain decision. Examples are linear regression, decision trees, rule-based models. Intrinsic explainability is suitable when interpretability is required by design. Moving on to post-hoc explainability. Here, the explanation is generated after the model makes the prediction. That is, after building and training the model, will apply post-hoc explainability. This is applied to black box models like deep learning, ensemble, etc. Since the model remains a black box, explanations are approximate. So the examples for post-hoc explainability are LIME, SHAP, GradCam, counterfactual. These are some of the explainable AI techniques to understand the model. And this post-hoc explainability is used when the model's complexity prevents us from direct understanding. Type of explanation. There are two types, global explanation and local explanation. We'll start with global explanation. Global explanation explains the overall behavior of the model. It focuses on the model as a whole. So the output is going to be a global feature importance, rules or patterns. Example for global explanation is feature importance plots or surrogate models. These surrogate models approximate the behavior of the black box models. So this global explanation is used to understand general trends or decision logic of a model. Local explanation. This is used to explain a single prediction or a single instance. It focuses on a specific data point. The output is going to be local feature contributions or explanations. Example for local explanation are LIME, SHAP, counterfactuals. Again, they are some of the techniques in explainable AI to explain single predictions. And this is used for understanding why a model made a particular prediction. Based on the model dependency, we have two categorizations, model agnostic and model specific. Model agnostic methods can be applied to any machine learning model. So they are highly flexible and works with black box models. The example for model agnostic methods are LIME, SHAP, permutation importance. So this model agnostic methods works externally without modifying the model, and it is used when explainability is needed across diverse models. Moving on to model specific, these techniques are designed for specific model types only. They are limited to particular algorithms or architecture. Example for model-specific methods are GradCam. This technique is majorly used for convolutional neural networks. Basically, convolutional neural networks are used for image processing tasks, video processing tasks. And then decision tree splits, layer-wise relevance propagation. This model-specific methods requires internal access to model structure or parameters. And it is used when we need to focus on understanding a specific model, such as neural networks. Based on stages of explanation, we have anti-hoc explainability and post-hoc explainability. In anti-hoc explainability, models are inherently naturally interpretable and explainable by design. So the techniques are applied to simple interpretable models such as linear regression, decision trees, rule-based models. And here the model's decisions are naturally interpretable. Anti-hoc explainability techniques are used when interpretability is required during model design. And then post-hoc explainability. So these techniques are applied after training the model. Explanations are generated after model predictions. So they can be applied to any model, including black box models. Examples include Lime, SHAP, GradCam, saliency maps, etc. The model remains a black box. Explanations are approximated by the post-hoc explainability techniques. It is used when the model is complex and it requires post-analysis. Expert focused explanation versus non-expert focused explanation. So expert focused explanations are designed for individuals with technical expertise such as data scientists, ML engineers, and non-expert focused explanations, they are designed for non-technical users such as end users, business stakeholders. In expert focused explanation, the explanations will be more technical and detailed, which will include metrics, equations, and things about the internal parameters or working of the model. Whereas non-expert focused explanations will be simplified, intuitive. There won't be any technical jargons in them. The explanation format for expert focused explanation is feature importance plots, SHAP values, model parameters, or mathematical outputs. Whereas when we look into non-expert focused explanation, the format is going to be simple visual explanations or explanation in plain language, examples, or explanations in the format of storytelling. The main purpose of expert focused explanation is to enable debugging, optimization, and detailed model validation. Whereas the main focus of non-expert focused explanation is to build trust and transparency of the AI model and understand the decisions of the model. Examples for expert focused explanations are again SHAP value plots, model coefficients, ROC curves, and for non-expert focused explanations, the examples are line visualization, counterfactual examples, decision summaries. So these are the different categorizations of explainable AI. Thank you.